see it's actually about to start. But the only problem is we can't say anything.
I guess.
They hear us chatting.
Cool. Do we have a camera?
Yeah.
Can I see it? Good evening, folks. We're just waiting for a few more people here in Clyde Road, and then we'll get going.
There's 50 on now.
50 online.
50 online. Very good.
Good.
That's good.
Few old guys now turn up. Well, I like it in person, but I missed it.
Yeah.
Okay, I'll get going then. Good evening, everybody in attendance and all online. This evening's lecture is on Introduction to Parametric Modelling. We have Christopher Short and Jake Hagan. Christopher is an engineer with Buro Happold, based in their Bath office. Originally specialising in large transport interchange structures, Christopher has expanded his portfolio to include the residential, sports and commercial sectors. Christopher has developed a keen interest in computational engineering early in his career, gaining experience on steel projects with complex geometry, long spans and modern fabrication methods. In recent years, Christopher has looked to use computational engineering on more rudimentary processes to increase efficiency within the design teams and external collaborators. Jake is an architectural technologist at 3D Reid for 4 years, based in London studio. Jake helped with the delivery of multiple new building residential schemes across the UK. From here, Jake went on to aid with technical design and digital management of projects within the commercial and aviation teams. During this process, Jake developed his awareness of digital processes and workflows, joining the digital transformation team in improving and future-proofing the ways 3D Reid work. His primary application within this span was the development of computational programmatic skills for drawing and model production. This interest has since developed into the wider application of computational process with a keen interest in implementing DFMA solutions from an early point in the design process. So thank you very much. You're more than welcome.
Thanks.
Thanks so much. Well, thank you all for being here, online and in person. As I was introduced, my name's Jake, this is Chris. I'm just going to give you an introduction to parametric design. Hopefully you all like the gimmicky GIF, which gives a taster for what we'll be doing today, and that's parametric. So, an agenda for what the day is going to be. Firstly, we're going to speak about an introduction from ourselves, and then what is parametric design. Off the back of what is parametric design, we'll say why is it becoming more relevant. Then Chris is going to talk about parametric design specifically within structural engineering. I'm going to go on to talk about parametric design's implications on architecture. Off the back of that, we're going to talk about a collaboration project that we did together using parametric design. And then, most importantly, it's how to engage the practice around parametric design. Following this, we'll be doing a Q&A, so if anyone has any questions, keep them all stored and we'll answer them as well as we can at the end. So, an introduction. Chris is going to start here.
Yeah, I mean, I guess we've just had a great introduction there, but very briefly, I'm a structural engineer at Buro Happold. More recently, I've moved into a bit of a leadership role within our structural engineering, the computational community, and that's just trying to galvanise more use of this tool set around the practice globally, not just within structural engineering, but within all elements of the practice. And yeah, I've been using sort of these tools for the last couple of years, so sort of along the journey for a little while.
Yeah, so similarly, not as long foray into parametric design as Chris for myself, but really been keen in driving the use of which within 3D Reid as a member of the computational team. That's me and one other person called Laura based in Manchester. And over the last recent years, we've been taking some renewed investment into R&D and putting that towards trying to keep in touch with some of these things within the industry. So developing and using parametric tools, not quite as long, but somewhere around 3 years.
Great, so a bit of a flavour for the differences between the two firms that we've got here. So I've been working with Buro Happold, like I said, now for about 7 years. Buro Happold's around 40 years old. They sort of born out of Arup in the sort of 80s. around about 2005 was sort of the first time we really identified that we had a lot of individuals who were using text-based scripting in various forms, VB scripts and some of the early scripting languages. Around about 2010, we started to have a bit of a community of these users. They were across the practice, but they were talking to each other online, trying to find little ways that they could try and create some efficiencies in various projects. And into 2013, that's when we started as a practice to really recognize the power that that would have on projects moving forward, and started to try and collate a lot of those skill sets together and try and adopt some teaching. 2015 saw the launch of our open source building habitats and modeling environment, something I'll talk a little bit about later on. And that's an open source tool set that we try to help galvanize the rest of the industry and not just ourselves. And right now we're basically at the point where we've got some in-house software development taking place, wide-scale cross-discipline adoption throughout the company, and we have training sort of internally and externally, because we, over this last sort of 20 years or so, have really seen the benefits that this can draw into the industry.
Yeah, and again, just to kind of talk around where we are on those individual journeys, this slide I think is more for my benefit than Chris's. Buro Happold are a very large entity with a lot wider reach and a lot more potential for investment into these sorts of things, so it's kind of really that juxtaposition against 3D Reid as a medium-sized firm with a good base of work across the UK, but it's not to say that working on these sort of things and investing in parametric tools is only for the top tier of people across the globe. So for 3D Reid, what that meant was a similar start to how it is, I think, for most practices, and that's a few people based in the company starting to come out of uni with skills or interests and a bit more touched in with what's going on within the industry in general, and then formalising those skills through patterns of, proving their worth to people in management. And then so that was in 2019, and that was myself and a couple of others really. And in 2020 from there was kind of a renewed focus on investment into R&D. And what that meant is, there was an understanding of wanting to try and move forward with the industry as it develops digitally. And that kind of formed into upskilling individual members of staff, because there's a skill requirement here to using some of these tools. And then developing kind of collaborative relationships with Buro Happold and a few other things. In 2022, that was a further integration of that, basically from feedback into things that we'd made already, and renewed avenues of interest within the company and the industry, really. And 2023 takes us into lots to do and trying to find the time and focus the attentions to get things done. So, next we talk about what is parametric design.
Great, so I think what we'll do is take it right from the start in its most simplistic form. We'll talk just a little bit about, literally at its core, physically what are we doing with parametric design, and then I'll explore a little bit further as how that is adopted within, well, first of all, structural engineering, and then we'll also talk about it from an architectural perspective. So, at its core, what I've got on screen here is just a very typical workflow that we might have on, I guess, a sort of a stadium-style project, where we're laying out the map of the workflow for that project. So, what different software packages might we want to use throughout that process? What are the inputs from external collaborators? So that's architecture, it might be site surveys. What information do we expect to receive, and how would we manage that? Is it going to be a manual data entry and into Excel, and then we read that somewhere else, or is it clicking some lines in AutoCAD? So out there, mapping that all the way across from inputs. We've got those processes in the middle. I might do some analysis in Autodesk Robot. I might do some hand calcs. And then at the end, we've got the drafting sides, we've got the Revit, the AutoCADs, and the drawing packages that we might release. Also might involve some sketches along the way, of course, to our clients. And so it's a bit of a roadmap of how that project might look. And I guess each of those arrows sorts of represents a bit of a manual entry that I might have to physically embed into that process. And obviously, we've all experienced it. You're working in that sort of output phase, and all of a sudden a change takes place. You physically have to go back to the start, and you have to then incorporate that process almost essentially again, working your way through each of these levels to make sure you've captured all of that information. It's all incorporated into your drawings, your reports, your calculations. And so it's a very traditional process. It works very well. It's been working for hundreds of years. And I guess that's the jumping off point for some of the work that we're doing. So next, very, very simply, what does that mean for parametric design? Well, on the top, you've just got an Excel equation. Very simple. 2 multiplied by 3, you can see it very clearly laid out in front of you, typed into the cells, and you've got your output on the right hand side, 6. Nice and straightforward. On the middle one there, we've got a program called Grasshopper. Grasshopper is a plugin for a CAD software, Rhino. So it's a tool that we use to drive the drawing software. It's like having Excel embedded into AutoCAD, for example. It's a driving tool. And again, you can see we've carried out the exact same function. So we're using a flow-based scripting language. You're typing the numbers in, you're plugging them physically into the process, and then you're plugging the process into your output component, and you're seeing the result. So it's a very simplistic way of representing the same function that most people should be comfortable with. And then again, on the bottom, you have Dynamo. So an almost identical process. Dynamo is a scripting language that sits within Autodesk tools. So Revit has Dynamo, the scripting language, embedded into it. And so what you can see on the right-hand side there is the Dynamo script that will control the model that sits behind it. So you're working in an environment where you can see your script embedded over your workflow. And again, on the bottom, we have the exact same equation. We've got 2 multiplied by 3 plugged into the process, and out the other end is the output. So at its core, that's really what we're doing. We're creating that workflow where you have your inputs, processes, and outputs sort of wired into each other with that throughput. So what does that look like on a typical calculation, for example? You know, certainly at Buro Happold, we use a lot of our calculations. We still generate them in spreadsheets just because it's so rudimentary. You have a lot of control over quite simplistic calculations. It's really easy to demonstrate kind of what you're working on at any one time. But if you turn on all the inputs and outputs and dependencies, this is the kind of map you would see. Things are linked. You know, you've got concrete linked into this, and you've got various equations that link together. On the right-hand side, I'm essentially replicating the same function. It's a canvas. I've dropped on lots of components that have functions. They will multiply, they'll move, they'll carry a whole range of processes. And I've got lots of inputs that'll plug into them, and they'll come out. And I've grouped those together, much like you might group them together in a spreadsheet with titles or on different pages. And they're essentially carrying out the same function, except Grasshopper on the right will be directly driving the drawing at the same time. Whereas with Excel, you might have to then take your result and manually go and carry out that process. So seeing one in action, you can see that there's a live link between the script on the left and you've got the drawing canvas on the right hand side. So my input is just a variable slider in this case. I've got a number that's going into 4 node components that I've dropped onto the canvas. Those have X, Y, Z inputs. So I've just put this number into a couple of X's, a couple of Y's, and I've got myself 4 nodes, 4 points. I've then wired those into 4 line components, and I've got myself 4 lines. And then after that, I've put them into a join, and I've got myself a join component. Now those are all obviously commands that you would be comfortable typing in AutoCAD, for example. You would type in move, you would type in line, you would type in join. And these are the very same functions that you can drop onto a canvas, except now I have the ability to actually manipulate that live in real time. And so it gives me a lot of control over what I'm seeing on the canvas if a change were to come through. And then over time, of course, you can start to layer up complexity into that process. You'll start with a very rudimentary point, might be an envelope of a particular profile or building. As over time, as you start to layer complexity into that script, you'll start to, in this example here, I'm sweeping that curve and I'm creating some surfaces that I'm projecting stuff onto. And in the last instance there, I'm just mapping with a very simple component within the software, a grid network to those surfaces. And over time within a project, much like any scenario that we're used to, you're arriving at a much more complex form, derived all from very simplistic tools that you can see laid out in front of you on a canvas. What does this actually look like, something of this complexity? Initially, the graduate in my team who came up with this script, it was a fantastic function, but it looked a little bit like this after a week of intense grafting. As obviously not something you would accept within an engineering environment. You need traceability, you need control, you need oversight, you need to be able to see what's happening. And so what we like to obviously encourage within the scripting environment is order, control, and descriptions and grouping. And this helps us to see which functions are doing what, you know, which bits might be alter for a particular design change. We can go straight to the part in the middle if we know it's exactly that the architect has asked for or a client has asked for a little alteration. So this will just be the geometry that I've presented there. But the reality is for a project, it's much more about the form, the function, and the materials, the section sizes, the naming conventions behind a lot of these sections. So throughout the project lifecycle, you're growing this scripting environment to a component that will ultimately manage that project for you in multiple environments. So over time, you're layering in that complexity, you're adding information, but you have full control over how that might work. Instead of going back to the start and carrying out your process again, you're really just changing the variables and letting that function carry out its commands entirely. But what does that look like in terms of the functionality? So I've spoken about those two key programs that we typically use in the architectural engineering industry. On the left-hand side, I spoke about Grasshopper, which plugs into Rhino, which is a CAD-based software. Online, they have an entirely open source library of components that people make monthly, daily, weekly. There's a couple on screen there, but you can search for any new tool set that someone in some random country might have come up with. It's a fantastic component for your project. You download it, it's now in your library, and you can start carrying out some new advanced functions. They might be very simplistic things, but they're really useful. And again, the very same thing happens for Dynamo, which sits within Revit. So all the time, new updates are coming through, new functionalities coming in, and you can adopt that into your scripting environment. So very simplistically, that's how, I guess, parametric design works, and we'll talk a little bit about that within the environment of structures in a minute.
Yep, so with an understanding of what parametric design is, I guess the next thing to talk about is why would you want to use it? And I'll start this off with a few kind of marketing-y spiel type quotes, but I think they're quite useful for just guiding our thoughts into this. And it's, technology is not neutral. We need to understand how digitization will impact the design of our buildings and cities. And then also, AEC professions are no stranger to technology, but we still largely rely on analog processes to go from design to implementation. So I guess with an understanding of that as a kind of guiding thought, I thought it'd be useful to talk about the policy change, which is off the back of our digital transformation drive as an industry. I'm sure all of you are aware of that digital transformation drive that is kind of going around at the minute. It's really interesting to see how the policy reacts to that, and I thought it was good to just put up a few of those documents which are sort of leading that from a UK and a European point of view. On the left there, we have a report called the Digital Innovation Imperative, and that's from a publisher called the Construction Innovation Hub, and they have some really, really good resources that I would say that are all worth going and reading. And then there's another one by the UK government, and that's the Construction Playbook, and that's really trying to drive the use of digitization through government framework projects, trying to stimulate the industry into moving into more innovative circles, especially with the adoption of DFMA and also a platform's approach to DFMA, but we'll touch on maybe some of that a little bit later on. And then from a European point of view, you have that report in the middle, which is about digitizing the EU's construction industry. And I'll read the quote also from the European Commission report there, and it says, "In terms of digital uptake, the construction industry is the lowest ranked economic sector in Europe." So lots of scope for change, lots of scope for improvement, and really just underpinning the justification as to the why, really. And then finally, just a collaborative report that's focusing on, standardizing digitization in the construction industry and the framework and all of that. And that's, again, supported by the European Commission. So lots of high-level top-down investment into trying to generate change within the industry. So off the back of that, I guess it's talking about then that capacity to affect change using parametric tools, and to throw a good graph up there to try and justify that. I like the one on the left most because the amount of effort you input is from little to heaps, which I thought was quite a good metric. Heaps of effort. So essentially on the x-axis you have effort, on the y you have effort, on the x you have a project design life cycle. So it's that ability to be able to impact change and it not cost much and not be too impacted to the design. So obviously the later you go through a project, you're going to be able to impact less change. It's going to be able to have to cost lots more if you're going to. That's coming back to what Chris was saying earlier about, that traditional workflow sketch. Someone changes something later down the line and it means this whole load of cost having to be used to rework all of that. And what we're trying to do is reduce this amount of effort at the earliest stage, or have it in a place so that if you do need to make that change, it's at the case of moving a slider or changing the variable, and that's being replicated through your design rather than someone have to sit for 2 weeks doing more calculations and laying out apartments. And then on the right, a graph again, which is hammering home the importance of the sustainability agenda also. So trying to embed data and make data-backed decisions to come to more sustainably driven decisions within a project lifecycle. It's way more easy to do that and reduce your carbon from an embodied carbon point of view at the planning stage. And if you have these tools, parametric tools in place to help you guide those decisions, then all the better off if we're making more sustainable buildings. So then, I guess, why is it becoming more relevant? So on the left there, the Morpheus Tower, Buro Happold classic, it really is talking about the contrast between buildings like these, which is what people think of when they think of parametric design typically. You know, you have structures that would be impossible to achieve without the power of computational design due to the nature of their complexity. And I kind of want to try and distance us from that because, you know, it's not only those sorts of projects that can benefit from parametric design. On the right-hand side, just to give a bit more of a typical example, you have the Autodesk HQ, which is in Toronto, and that is just, you know, it looks like a rectilinear commercial building that you'd see anywhere, but really what they did when they designed that is feed in so much control to every aspect of like embedding data into the design parameters and the initial consideration. So what you have is occupancy-driven parameter control, trying to make the building more efficient, not only structurally, but also a nice environment for people to live in. And all of that is, you know, malleable at the earlier stages, so we can come to more data-backed decisions, in essence. So it's not just double curvature structures that can benefit from this, it's, you know, your rectilinear commercial ones.
Perfect. Great. And yeah, so let's touch a little bit on the uses of parametric design within structural engineering, certainly from the perspective of the work that we've been on in the last couple of years. So obviously you just saw there, I think the jumping off point for Buro Happold was these large, possibly stadium roofs, double curvature, the places where it was just absolutely required for the project to take place, whereas nowadays actually we're using it more across the board on much more generic commercial residential buildings, because we're finding it just drives in efficiencies across the board. So, evolution of co-design. What we've got there is, you know, on the left-hand side, model making, people standing in a room, possibly sketching, you know, collaborating in that really hands-on environment. You know, a really traditional method that, you know, goes back thousands of years. I joined Buro Happold about 7 years ago, and for me it's always really been that middle section. So your first principles, your pen and paper, you know, really grafting out your calcs, making sure you've got a clear understanding of the principles that are taking place. You know, the last sort of 10, 15 years has been really moving towards that BIM environment as well, so starting to embed more information of our designs in possibly Revit or Navisworks or some other environment like that. And that complements that model making hands-on approach on the left. It does not replace it. It goes hand in hand with that process. You just have a much broader understanding of what you're actually dealing with. And likewise, as you move towards the right-hand side and sort of the environments that we add into this process now, your scripting based processes complement both of the processes on the right. They do not replace it at all. You need all of that to work together for your project to be successful. And I think that's possibly some of the areas where the lack of understanding and the working of parametric design has come. It doesn't replace, it just merely complements the work that you're carrying out. So interoperability is probably the area that it benefits us the most. We're not trying to change the way that we design steel beams in Autodesk Robot. We're not trying to change the way we do it on pen and paper. I'm really trying to support that process around what I'm doing. So I'm still carrying out my very traditional design methods. Typically I would use Robot, we might use TechHub, we might use 2D design. And I'm still drafting my models in a CAD or Revit based environment. But what I'm doing now is I'm supporting that process by creating a script. That's what you're seeing at the top there, the representation of my script. And I'm allowing that to then push all that information both to my analysis model and to my drafting model in a single sweep. I don't have to then build the analysis model by hand in an analysis package. I don't then have to then work with my technicians to try and create the 3D model at a different time. Every time a change takes place, I might have to then make that change twice. So by allowing this parametric design to exist, I can create a single source where that takes place, assign all of my properties, all of my geometry, everything I want to exist in that single source, and then push that to each environment that's required. I might have 2 or 3 different analysis environments that I want to check for this building: concrete, steel, global stability. That can all take place from that centralized model, and it just starts to save time and allows me to focus on much more important aspects of that design. So what might that look like, creating that structure? A very simple method. It's very similar to what you would do through the manual process. You're just laying it out on a canvas. I'm creating my grids. I'm then finding those intersections, trimming the lines, dividing those lines. I'll be projecting those lines up to the right level. It could be a flat surface, it could be an angular surface, and starting to group those together into primary, secondary, tertiary beams. And then that last part is actually really that new element to it. You're starting to assign the parameters that you're interested in. Section properties, material classes, any comments that you want to attach to those, they embed into those objects. And that's a very traditional process. If you were to do that manually, I would sit down and work through those processes. Except with my script, I'm laying it all out on that canvas and allowing it to do the work for me. What that means is when we move into the drafting environment, you actually have a lot more control over the level of data. I did that in the scripting environment, and I'll never have to do that again. Once that was built, that script, I never have to regenerate that model. It's an automatic process. I change some variables and I regenerate my model. So that gives me more time now to start playing around with various parameters. To work with my technicians a lot better, I can embed comments and filters into those. So automatically we start to have more material class, more grouping of all those elements, and we start to be able to have a lot more control over how that looks. This then starts to open up windows for how we work with the contractors, creating different regions, stability zones. It's just a much more vocal view of that structure. So, secondly, I think first impressions is something that's really useful for. So on screen is just a very typical load takedown. It's something that's really useful for us to be able to see where the forces lie within a building. It's really simplistic and it's really hard to go wrong. I think that's always really useful to have in every project, still today, even if you're going to be using script-based environments. But actually sometimes it's much easier if you've already got a 3D representation of that to get a quick visualization of how that might look before you have your nice physical hard copy ready for filing. So on screen here we've just got the 3D model that might have come from an architect, a really quick rough and ready thing, but it's still good enough actually for us to just chuck through a scripting component that someone else has created and signed off on that just says load takedown or load paths or something similar. I've not had to go in and generate a robot model. I've not had to go and generate another analysis. I can just do a quick, get a first impression on how that might look for some scheming exercises. This complements the previous slide. It doesn't replace it. You still need accountability, you still need traceability of how that all operates. But what it allows for is just that confidence in your early stage design, and it helps you get off the ground on a project. And then next, what we have here is design. So design creation, subframe analysis. On the right hand side there we've got Autodesk Robot again. Hopefully an environment that a lot of people are used to. I like to build up my models traditionally within Robot as opposed to tracing them onto the background of a CAD file, which some people do. But on the left hand side here we've got the Grasshopper script on top, we've got the Rhino CAD file on the bottom, and what you're seeing here is the pushing and pulling of that data. A lot of engineers are still more comfortable creating their designs in Robot. You don't have to start in the script. You can start in your analysis model, extract the information into your code environment, play around with it there, push it back. And so it's a two-directional process. You can allow for each person within the design team to work in the environment that they're most comfortable working in, but all you've done is globally increase that visibility and the speed at which that can take place. So it's still a very collaborative environment. You can still use your traditional methods, but you've just added a layer of complexity on top of that. Next is something that I guess we do most of all at the start of a project, your very classic model laundry. Early stage design, we get various file types of projects coming through. So it could be a SketchUp file, it could be photographs that we've got to try and quickly turn into a drawing. It could be hand sketches. But what we do is we've got some scripted processes built up that just allow for the simplification of that geometry to nice clean lines on the right hand side there that we can then use for analysis and take through. And once you've set that up in a project, every time a new design iteration comes through, you already have that workflow set up. You do not have to repeat yourself. You can get to that clean analysis stage at a much quicker iteration. And that all comes back to that being able to implement change at an earlier stage. It supports that process. Reviewing of work, I think, is a really useful tool that I probably use it for almost the most. Being able just to challenge the designs that I'm seeing in front of me without having to do this iterative back and forth with various drafting team members, technicians, and engineers. There's a huge array of functionality that people across the world have built up within these scripting packages to carry out reviews. So here are just two examples from our project, and you can see the scripts below them that carry out that function. So they're relatively small scripts, a couple of little commands. On the left hand side there, it's just pile proximities under a raft of existing piles and some new piles that are going to go in alongside those. They just nice and clearly show where I should be and where I shouldn't be making placements. And on the right hand side, very straightforward functionality, grouped by colors of orientation and angle. Again, it's just going to highlight to me really quickly if there's a minor error in the way that that's been created. If you're going to do that manually in Revit, you might just have to draw dimension lines everywhere and do a quick review of those. But this is just a bit of a quicker way that I can see if there's going to be possibly an error in the model. But you can build up a whole array of those into the project depending on the complexity of what you're dealing with. Next, I think we touched on something which is design for manufacture and assembly. It's obviously a growing field within the engineering and design industries. And what we've done, because this building has been built up in a 3D environment, so a scripted environment, the initial intention wasn't to necessarily display how it might go together, but because we had that at our fingertips ready, it had been developed in that environment, we figured we might as well give it a crack and see how that goes together. And this is the kind of result. It really helped the contractor visualize the volumes of storage that might be on site and the way in which it'll be constructed over time. Of course, there's many software platforms out there that assist with this already, but what this has done is allowed us, the engineers, to also see the impact that our design has on that process, and it just draws more people into that conversation. So you're not, again, you're not replacing other processes that exist, you're just allowing more visibility within that environment, and that just helps more knowledge within that space. So talking earlier about the workflows and allowing people to work with traditional methods, many people still would prefer to work with their hands-on Excel-based or CAD-based environments. They're really intuitive, they're simple, there's a limitation on functions, but that doesn't mean it has to stop there. A lot of the toolkits that we talk about today don't just exist in the scripting environments. It's about embedding more functionality into all those environments that we already work in. They're all script-based, but they're sometimes behind the closed doors, so that we can use these more traditional methods such as laying out grids, creating very generic floor plans for relatively rudimentary buildings, but then by using these parametric processes, we can push them again to multiple analysis packages at the same time, and then take those results back into Excel, possibly, and then move those into Revit. So again, you're just creating that feedback loop that allows you more time to focus on that design. It's not always about creating complex scripts that carry out complex functions. It's just about giving yourself more opportunity to carry out a better design. And again, you're seeing a very similar thing here. It's the live adjustment of a building. It's that early stage iteration where you're working with your client through what the outcomes of certain design decisions might be. You're able to get to those results much quicker. This is not replacing the final design, it just gives you more ability to challenge those design decisions at a much earlier stage. And of course, again, you have that flexibility to move between programs in a much easier environment. So, after talking about all of these workflows, I thought I'd close with a couple of some of the origin stories of how we worked in it. So, Viva Stadium, I'm sure everyone's familiar with the stadium that we got here. This is one of Buro Happold's earliest football stadiums that we worked on over time. This whole stadium was designed with a small amount of scripting on the roof, but largely with quite traditional workflows. Today, what we use, again, is very simple geometry alterations. It allows us to visualize the impact that some minor alterations might have on visibility, span, tonnage around that structure. And that has all been developed with the use of the tools that I've just spoken about. All it really does is allow more interrogation of your design in this functionality. But today, we're taking that to the next level. We're collecting much more data around the practice. So this is really pushing it to the absolute limit at this point. We're doing studies on noise analysis, we're doing studies on crowd analytics, and we're doing studies on the geometry of bowls. We're collecting a huge wealth of data that we can start to use to feed into the inputs of the scripts that have been created over time. Now that we have these scripts in place over the last 15, 20 years, they can be reused again and again. So now we're actually playing around with the types of inputs that we're putting in to try and improve the outputs, because it's no longer about tweaking the geometry, it's about really improving the performance of the entire project as a whole. And what that's led to is one of our most recent stadiums where, in terms of form from the outside, it's a relatively similar looking building. It's double curvature, it's a big bowl, it's lots of concrete stands from the stadium show before, but ultimately the experience within the building and the functionality of it in terms of the client's brief has much more data-driven design embedded into it. And that's the kind of direction that the engineering industry is moving towards.
Great. Yeah, thanks, Chris. That was really interesting. So then to talk about the implications of parametric design on architecture specifically, here we have a typical diagram of the way we work, similar to Chris on his first slide. It's that relationship between the old and the new. We've all agreed that we want to move towards delivering more excitable, sustainable designs that we can do using less effort and time into those first original design stages. So we focus on the more important things, such as reducing carbon and making buildings that people can enjoy spending time in. Here we are on the left in our kind of traditional sense of working. This is still happening, obviously, every day. This is people breaking out into workshop spaces, sitting down and sketching out ideas. And I think the key thing to start off with is that we're not trying to tear up that rule book. Everyone still needs to work in this kind of organic way, but it's how we plug into that with parametric tools to try and make their life easier, so that when it comes to having to adapt the change and move the change, people aren't sat there, into the late hours moving model components and doing all of these bits. They're just have complete control from the outset over their designs. And what that meant for me and Laura is really, as part of this initiative that we had, which is the generative design team, is listening to the way people work. So it's just inviting yourself along, eavesdropping in, going to design workshops and just hearing the way that people are developing a design, working organically, and then you can start analysing that with a specific parametric mindset once you've started developing these sort of tools and this way of thinking, and distill what they're doing in an analog way into a workflow and then a potential set of tools, giving them the opportunity to say, well, here, this is something you're doing at the minute. Well, here's something which can help you do that, and you develop it with them, and hopefully help save them time and move towards a more efficient design process. So the first example I want to give is probably the most common and well-established facet of parametric design, and that is, of course, just geometry manipulation. So the way this looks within architecture or within some of these tools is allowing us to facilitate rapid design iteration. So no longer when we have a specific portion of a building that we want to interrogate and stretch the shape of and manipulate with the forms, No longer is that a time-intensive task, where someone has an idea and then goes and sits down at the desk for a week and draws it. And then you come back at the end of the week and you go, no, that didn't work. All right, well, let's spend another week trying a different option. That doesn't sound like a sensible workflow, does it? So instead of that, you just distill everything down into these number of variable sliders here, which let you control a specific portion of a design in its the faceted louver array around the curvature, the angle of the louvers, the number of the spacing, the X and Y length of the bay, and then the height modulation of the space. And all of these, you're not fixed to these options. It's just allowing you to completely control what you want with the geometric representation of a form. So we're controlling the louvers in this space, ensuring that our facade articulation matches the building form that is stuck behind that. So rather than, you can imagine someone going, well, let's make the building this much higher and change the radius here, and then someone spends 6 hours trimming each one of those louvers down to the form that sits behind it. It's just like instant geometry manipulation, and that's unlocking time for us to spend doing what we want to do, and that's focus on the important factors of designing, not doing the job at hand. It's making sure that we have adequate daylight conditions and thermal performance that we need, all sorts of things. So that's the first example that I wanted to give. The next is maybe less commonplace when people think of parametric design, and that's ensuring regulatory compliance. Something I thought could be pertinent to talk about within this presentation, because it's not only is it collaborative between a structural engineer and an architectural practice, but also, post-Grenfell world within architecture, it's incredibly important for people to be more and more aware of fire compartmentation and design in general, from an early stage of a project all the way through to project architects. So this example here is a cavity barrier modelling script that we developed, and that enables us to, given, this is a traditional environment where you have a Revit model that a structural engineer has developed linked into our architectural model. That we know that our cavity barriers need to exist somewhere in this space. Typically that is undertaken in a 2D environment, just in a drawing, someone draws a box. But as we move towards a more model-intensive industry, and also a more of a 4D construction type planning and phasing of our designs, we want to be able to see these components not just as a 2D entity in a PDF. So the way that this works is that you select a profile for your cavity barrier, you hit play on the script, select the slab that exists in the structural engineer's model, and that then just rips the geometry from that slab into our scripting space, sweeps the profile of that cavity barrier around the space, tells you that it's been successfully modelled. And what that means is then around to the extent of this floor plate, if I just cut the section box of the 3D model into the building itself, you can see that down within this space we naturally now have a 3D component which represents that fire barrier. So that means visually it can never be missed, it's always going to be there, and people can start having a greater understanding of the importance of this as a component within our current designs. Not only this, if I just isolate here, you can see a zoom out, that's that floor plate. So that's the cavity barrier around that there. People can edit it as needs be, and also it's represented as a component in our 2D drawing still. So it's not that they have to draw a 2D thing which can be disconnected, it's treating the model as that element which has so much more of an importance in terms of not being able to miss something such as a cavity barrier. The next example, talking about reducing waste in design. And just to read a quote from the Irish government, construction and demolition is the largest single waste stream in the EU, making up around 1/3 of all waste produced annually, so it's critical that we manage it effectively. So it's commonplace. I mean, I know people can be forgiven for thinking that waste management is a contractor's issue. They're procuring, they're cutting on site, and they're the ones who are being inefficient. But there's a lot that we can do from a design point of view to try and minimize waste before we get to site. And that's optimizing our designs using parametric tools to have the data up front to know that you know, if we're changing something here or tweaking something there, can we do it in a more optimum solution that we can measure and quantify? So just to explain the diagram that we have here, what's going on, you essentially have a bounded polygon, which can be of any shape that you draw. Within that, we have an arrangement in a specific bond, in this case herringbone, just to try and be fancy. But in essence, what it's trying to do is just squeeze a pattern of rectilinear objects within inside this space in the most efficient way, which reduces the number of cuts that would be required on the perimeter. So architecturally, this is brick patterns, tiling arrangements. This might be a wacky patio or something, but structurally, you could have, you know, if you have a massive floor plate or something with a few weird angles and you've got precast plank solution, you want to try and lay those out in the most efficient way, which is going to reduce the weird shapes or the special objects or any cuts that they might have to do. So you can then just quantify the number of components within that. You have the number of hole tiles, the number of cut tiles, the number of cut tiles which are less than a certain threshold for tolerance, and of course that's all just parametric, so you can tweak that tolerance if you want. And then the total number of tiles and then overall score. So the lower the score, the less amount of cut objects. So the green outline ones in the centre are obviously not cut. The solid green ones are the less than 5%. And then the brown components around the edge, they are cut, but the component is possible to be reused. So not only is there value in knowing the least amount of cuts, but rather than cutting an object and then throwing the rest of that waste away, you can cut that object and know the exact location on the perimeter where, if you wanted to continue the bond, that pattern could be continued. So it's all about trying to reuse as much material as possible. And then essentially the variables you have manipulation over here as just rotation of the entire pattern arrangement and the bond, and then the X and Y movement of that. So as you see it rotating through the shape, you see the score updating there for the number of cuts. And the pattern updating as per if the object is cut or not, and then tweaking in an X and Y to try and find that. Yeah, so really that's trying to optimize designs at an early stage prior to construction, really helping to fight the climate crisis. And then just a final example I wanted to give is some other people who have, similar to Buro Happold, been investing in this space for a lot longer. And this is really the power of being able to, what I said earlier, of putting the time into our hands to be able to do what we want to be able to do, design good buildings that work for people, not worry over the particulars of placing certain things and doing specific things. So the way that this script works is inside a Revit environment. They have built a library of previous apartments that they've designed. So there they have a data set, basically, that they have of previously delivered projects. So they know they're compliant, and they know they were designs that they were happy with. So rather than filling all of these empty apartment floor plate spaces with walls manually and placing beds and, you know, placing all of these components, which is just time consuming, and checking the regs, what they have is this script for just dropping down a front door, and it gives you a library of previous apartments of the same area, the same tenure, and that you've used before, and it's just placing everything in there for you. So it knows it's a match. It's using a data library of projects they've delivered previously. So if we're happy with designs we've delivered before, everyone has a data bank of jobs that they've worked on. They're leveraging that information rather than it mothballing on a server. They're using it as an example of work they've done before and letting them generate their apartment layouts for them. They're not going to be perfect. They're going to need tweaking. But in essence, it's saved 95% of the work. And then you can focus on, again, all of the important things that you want to be doing.
Cool. So, let's talk a little bit about collaboration in design. So obviously we've got an engineer and an architect here. These processes don't just exist solely within our own disciplines. They work cross-discipline within a practice, but they also work with collaborators, contractors, architects, and it just allows for that whole process to be combined together. So we'll talk a little bit about some R&D projects that we've done together over the last year to try and improve those early design stage efficiencies that we often find ourselves trying to battle with possibly later down the line when we wish we had more time at the start. So we decided we wanted to achieve used the reduction of embodied carbon within a design as our target, something to work towards collaboratively. We wanted to challenge the traditional methods of collaboration, so the emailing backwards and forwards of documents, possibly Dropboxing, possibly even using BIM 360 as a repository to drop files. We wanted a much more live link between the workflows that we had, possibly linking some scripts together. We didn't know how we were going to do that. We wanted to develop a tool that was driving the design with data, and then create a data link between our scripting environments. We both actually work in 2 different environments. We wanted to see if there was a way to link those together and not have to upskill in something new all of a sudden. And this would ultimately add value to future projects and share this around. So a little bit of a workflow of how that ended up panning out. So this is still using our traditional workflow sketch to help plan ahead. So on the engineering side, we talked about reducing embodied carbon. That quite often comes down to reducing component volume, so the volumetric load of concrete or steel on a project. Quite often that boils down to reducing spans if we're talking about a very classic bay grid type structure. So really on the engineering side, we're looking at a way to optimize structural grids within any given floor plate to ultimately work its way back to reducing the embodied carbon. So this was really the goal that we set ourselves on the engineering side within this particular collaboration project. And yourself?
Yeah, thanks. So then how that was realised architecturally. So we want to reduce embodied carbon. A key method of doing that architecturally is reducing waste through design options, basically. How we're going to reduce waste, and a really key facet of digital design is DFMA processes, as Chris touched on earlier. So if we want to be able to engage with DFMA processes earlier in a project, so not just as something that's retrofitted on at stage 4 when we realise that there's an opportunity to do it or the client has decided they want to, it's trying to drive that from an early decision and underpin some of that information into a concept stage massing. And then again, how did we want to achieve those shared goals? And that was really collaborating in a digital workflow. So again, just to touch on the importance of DFMA and the role that played within as a design driver within this project. There are so many benefits that the industry is waking up to, particularly being driven by contractors, but also now and more as designers, people are being aware of the options that they have. And really, economies of scale, utilised industrialised manufacturing, less noise pollution on site, faster delivery of projects on site, less disruption, less waste in a controlled environment, less on-site energy use, encouraging circular economy. It just speaks for itself. There's just makes so much more sense to leverage this industrialised manufacturing approach, delivering components rather than delivering parts and building components. So this supports or goes hand in hand so well with digitalising in general. The manufacturing industry there's lots of graphs of showing that the investment they've had and the amount of efficiencies that they have seen through investing in that digitalisation of components and focusing on that. Doesn't mean that every single car looks the same. We're not working to a solution where every single building looks the same because they're built out of parts in a factory. It's just about trying to leverage efficiencies from those processes. And then just a video about how that looked like in terms of the realisation of the project. Architecturally, we wanted to be able to manipulate a building's mass with the understanding that you were going to panelise the facade components later down the line. So rather than having 60 unique different panel sizes and types, we wanted to be able to manipulate a mass based on a regular component module. It could have different materiality, but essentially the base frame was to be the same system of regular modules so that each elevation could be divided exactly by the length of one facade module. So, was that video playing? No, need to click on it. Playing? Not playing. Okay, we'll talk over it. In essence, what this then looked like is once you'd manipulated this building massing to suit that regularized facade module, that building footprint would be pushed into the interdiscipline environment that we were talking about, so that Chris didn't have to jump into Dynamo to take the geometry out, because I'm working in Dynamo for Revit, he was working in Grasshopper for Rhino. I pushed the geometry which represents the floor plate into Speckle, and then he can generate some grid options from that.
Yeah, and then once in the environment that I was comfortable working in, I had received this floor plate. I was able to generate, with some scripts that we have in-house, quite simple number of grid arrangements, so created automatically 5 or 6 grid arrangements. Ultimately, the scripts just look to create a few more than you might come up with individually, so they're looking obviously for the facade lines, they're looking for those key internal breakpoints, and then a range of different subdivisions between those. So instead of just working to your 5, 6, 7.5, 9, 10 sort of standard 10 grids, we'll let this script actually just run away with whatever it found to be the best at the time. And then at a later date, we would obviously rationalize that to something more appropriate for site. But for this exercise, we allowed it to just kind of find what it thought to be the most efficient at the time. Once I'd found those grid arrangements and done a bit of an interpretation on it, you have to add a little bit of interpretation to what's coming out of these. I would send those back through the same essentially telephone line that was built into these scripts back to Jake, and he would be able to carry out the rest of the sort of facade study.
Yeah, so then once Chris had developed these grid options, it's not to assume that once I had developed a footprint that suited my facade modules, that would mean Chris would be completely happy and this would be a completely perfect footprint on the first go. I would have to download those grid options and then interpret how that panelization would fit within inside that grid. So we're trying to have facade panel modules which are always meeting against the column. You've got those nice regular components of maybe 4 panels of a set size between a column bay, and that means that the regularity that we have, the simplicity of design, and the construction abilities of linking with DFMA processes are greatly increased when we have regular construction points. Simplifies the connections, simplifies the details, and really just making sure we're trying to standardize everything and move towards this component-based typical design. Off the back of that, at the minute I just had 4 generic typical panels there, and in the video what you'd see is that essentially the new building outline, once we had a structural system which we were happy with, would push all of those facade panels into the model for you, so that your entire building is just clad with these regular modules with different materiality options embedded in them as digital components. So this is working towards embedding digital design with DFMA into an architectural model, so you have this library of ready-built modules and components which can be switched out for factory-made options. So flying around the design and seeing how the impacts on the floor plate, put some window components in, and all of those have all of the manufacturing data embedded in. So you've got these stage 4 ready objects being loaded into a stage 2 job, so that when you're coming into having to make these decisions earlier and lock in a manufacturing type or a construction type, the components work because you're building them off a resource of existing knowledge. So it's really then pushing that, going back to the graph at the minute with the effort on the y-axis, it's bringing that effort into the earlier stages of the design, so that if you need to make the changes you can, and you're benefiting off the distribution of work onto the manufacturers to deliver the project for you. So then just a bit of a nod towards the tool which enabled us to work in our individual spaces. This is called Speckle again. It's one of the open source softwares in the industry at the minute, allowing us to work within any one of these file types. It's not limited to those ones there. It seems to be just snowballing into whatever you want. In essence, it means that regardless of your environment, it doesn't matter who's working where. It's all about that interconnectedness of data. No longer does it matter that someone has a file type that's not supported. They've made a tool which can allow you to transfer those between with no real issues.
And then alongside Speckle, something that we've developed in-house but have released, again, open source in a very similar manner. It's the Building and Habitats Object Model, so the BHoM. It's an environment that looks to just translate engineering and architectural data into a common code that can then be pushed out to any other toolkit. So what it means is that, again, we can not have to worry about unsupported file types. We can very quickly start to move our models around. So in the videos that I was presenting earlier, where someone was working in Excel and then pushing some data into Autodesk Robot or into Revit or into eTabs, this was the environment that we were using. This can be used by anyone. It can be downloaded online. And it just allows for that seamless flow between clients, architects, collaborators, contractors, so that we can get to the more meaty stuff much sooner and actually try to tackle some of the problems that we've talked about today. So the building and habitats object model isn't just about sharing data between platforms, it also has some functionality to it. So the object model is what I've just talked about, moving information between platforms. It also has what we call the engine, which has an ability to actually make decisions. So tidying up models, possibly carrying out some daylight studies for building services engineers. It's a cross-discipline platform. It has adapters, which I've talked about, so it just links to a whole host of proprietary products. And we're working on now the user interface, which allows for a much more clean visualization of the work that people are working on in different environments. And so that can be accessed by anyone, and it's actually being developed by not just Buro Happold, it's open source, so we have people across the world who are actually feeding into this now to try and grow its capability. So at the end, creativity improves coordination and the redesign cycle. This is really what we were talking about at the start, where we're trying to draw a lot of that effort back to the start of the project, where the cost is minimal and we have the biggest impact on possibly the sustainability credentials of a building, reduction of waste, and ultimately getting towards the goal of the brief. By looking to relate all of these different platforms together in a much more cohesive environment, I think we can get to that in a much more clean sort of manner. So very finally, engaging the practice, which is a really, really important part of this process. There's time and time again where a lot of companies have tried to actually draw this into their practice, but the engagement hasn't quite been there, because fundamentally it's not a new tool, it's not a new piece of software, it's a philosophy, it's a culture that needs to be created around how this works. Because you're not just using a new piece of software to design a new building, you're asking people to recycle scripts, to embed them into future processes so that they can derive that value out of it. So we have a learning and development program that's been set up at both companies. We have training material that's online, but there's a host of material on YouTube, on various websites that are all free and open source to train up individuals in either architecture, in all the different engineering disciplines. Within the company though, we promote that as CPDs, and we give out certificates that people attend. It goes towards chartership training because they're learning a new skill. Workshops can be internal if you have internal people who know. Most companies will have junior staff who do know how to use these tools. There's just not really an environment that exists for them to use them on projects. So actually nurturing that and asking them to speak a bit louder and try and draw some more people in will often work. And we have created also an internal development route for those who wish to embark on that journey. What does a grade 1 versus a grade 2 skill set look like, and how do you move from a low skill to a high skill? And that can be recognized by the practice, and that draws more people into that process. So providing that learning route is a very key part of adoption within a firm. Something that's quite, I guess, unique to us is that we host a biannual event. We call it the Academy. It just allows for everyone who's interested in this space to get together and crunch out some crazy ideas and come up with new things that we might work on. So this is a global event that sort of spreads over a week, but it happens also at an industry level. So the Institution of Structural Engineers host very similar events where they get people from all over the industry to come together and have a fun day where you get set a challenge and you see what people can come up with. The stuff that people come up with is absolutely crazy. It's amazing. If you allow people just to freely create some of these scripts in a unrefined environment, some of that stuff will be insanely useful on a whole host of projects. And we often make this stuff open source because it's collaborated by everyone, and you really do find out sort of the weird and wonderful ways that people try to solve problems through these sessions. And so they're a great way to foster that. Like I said, there's progression and development. So here's just a set of competencies that we adopted. They're almost identical to the structure of the iStruct and the Institution of Civil Engineers in the UK, where you've got knowledge, experience and ability, and you've got different levels within that. And by giving that out to the public certainly within the company, we found that loads of people were starting to register these as interests and development routes because they were interested in getting involved. And so just providing that platform for progression was a really important way to sort of foster that adoption. Script reuse and return on investment, it's really difficult to try and pin down what the return actually was after you've spent months using these tools. I guess the way to define it is it's not really about the investment return on a particular project. Sometimes when we use them on projects, the project couldn't have happened without it. Sometimes it could have been done, it might have taken longer, but who knows, there might have been a change down the line. It's really difficult to pin that down on a project by project basis. The way in which we like to look at the return on investment is over time. And this is what I mean about that culture that has to be instilled into a business. The first project will inevitably happen on a very typical basis. You'll spend a huge amount of time on design. You'll spend a bit of time during construction where there'll ultimately be changes. And then you're into the operations phase. But actually, if you've used a scripting ability within that process, you've got a better jumping off point for your next project that's of a similar scale or a similar industry. You can start to reuse those scripts on that next project. And you've got more time then to create efficiencies on that next one. And the point is that over time, there's an iterative improvement that takes place either on a project or a sector level, a business level, or the entire industry as a whole. A lot of this stuff is open source. People are sharing the ways in which they do it. And over time, we're looking to improve everything that we're doing. So it's not a project by project level. The difficulty is asking people to accept that the savings come later. And that's obviously the hardest part of this entire show. But one of the ways in which we're trying to celebrate all of that is, we have this network internally. There's a network that exists across the industry. We're trying to connect as many people together as possible who operate in this space, whether that's in a structural discipline, architecture, building services, construction companies. There's lots of environments online that people exist, so this is the one that we use internally. This is how you find someone who's worked on a similar type of project to you somewhere else in the world that might know how to use that tool set. It's an area where we just connect people together. And that's not just Buro Happold, of course, that happens on forums, on every venue. To try and back up all of our claims within the practice, both of our practices, we feedback forums, very traditional methods, and also usage, metrics. Usage has been growing massively over time. And this is from 3D as well, right?
Yeah. So it's really just giving people the opportunity to feedback onto what they're using. Just if it's not working for them, to be able to ping an email over to like a help forum, which is then internally managed, and then also being able to track what people are actually using, to then see if, we spend time using this, making this, but we see that no one's really using it, and then that can let you reflect on that and say, well, why might they not be using it? See who has used it, ask some questions on how it works, if it wasn't working or for what reason they didn't like it. Really just helps quantify some of the justification to where to spend time. And that draws us to our end. If we have any questions, we'll take them now.
Thanks.
Can I get the questions going, or do you want to?
Yeah, you go.
The
Mike's there, yeah.
Make sure it's turned on.
I think it was.
Hello.
Yeah, there you go.
Folks, that was a brilliant presentation. Thanks very much. I've got a few questions here. I'll try and stick to just one or two. At one stage, you presented a slide about interoperability, and I think what you were getting at there was time saving. Has there been any attempts to quantify time saving across projects? The actual quantifiable time saved through, having a single source of truth in your geometry and then pushing that out to an analysis model that would have taken an engineer X amount of time, and a Revit model that would have taken a modeler Y amount of time?
I guess for the frame that I presented, the sort of the multifaceted roof that was on screen, we almost possibly wouldn't even have attempted the roof in that form. It grew to that form because we had already started down the process of scripting it. So it's very hard to quantify that time, because your project ends up going in a direction because you have the ability. Whereas obviously as engineers, you have the ability to influence design to a degree within the architecture, and either the simplifications that take place, or there's you make things more complicated over time because you have that ability. So it's difficult to quantify the time, because you might not have gone that route if you didn't have that ability. But certainly we tried to start modelling that roof, that one that we showed. So there was multiple work planes within Revit that would have had to have been used to model it, and we got maybe a third of the way through, and it was weeks had passed, and we knew there was design changes coming up. So it was really like a stressful time, and we were like, we have to change at this point. And it got to the point where that roof is, well, it's seconds, but it took weeks to develop the script, of course. And so the stressful part of that is you have nothing until you have everything. And that's a really difficult thing to communicate to project leaders, to job leaders. Whereas if you're manually developing it, you have a linear progression, and you see it come together. Whereas if you're asking someone to develop a script, it's a blank canvas in Revit until you can send, and you have, obviously you can incorporate updates, but it's a whole new way of thinking about the time.
Yeah, you almost need to be able to quantify time savings on a script which is so intrinsic to the development of a project, like Chris mentioned with that one. The only real way is if you had someone doing it manually at the exact same time too. And that is definitely a good starting point to base yourself at. We spoke about that with Gary when we were talking about how you would start integrating the collaborative tool that we tried to do into a real project. And you should never just dive in and go, we're going to use parametric design on this project straight away, as the first test base, and then, because things do go wrong with it. So you need to be able to run it alongside, iron out the bumps, let the project develop naturally in its own environment in a typical state. And maybe that's the first testing bed for where you can start seeing the time savings, because if you have a team of people using parametric tools to try and deliver the same building with the same input from the project team in terms of design change, stakeholder input, but in complete isolation from impact on a real world project, for the first case to let you iron out the bumps and do that. But with at least with the usage graph that I showed, some of those are mainly from not geometry creation scripts, but like process automation scripts, and those we have quantified time savings from, because it's just the fact of trying to do a small-ish task that would maybe take you half a day manually, and you just literally, I've just pressed start on a stopwatch and did it manually, and then when I finished doing it, I just pressed run on the script and just timed it on the stopwatch, and it's like, I don't know, some of them are like 60 times faster. It's just like, it depends on the script really.
No, brilliant, thank you. Just one more question from me. I was happy to hear you say that, or Chris presented that, we still, like the I-Struct-D exam, for instance, was today, and those first principles, those basics of sketching and load paths and all, that always comes first. And then this parametric process then informs that once you've got those principles together. So I'm glad that you put that in there. But then I guess for, let's say if there's any small practitioners in the room and they want to get going and they want to start their parametric journey, where would you recommend that they start, and how would you recommend that they start?
I mean, there's a huge array of, ultimately I guess the benefits to this process is ironing out those repetitive tasks that we do. There's lots of benefits that we've found to footing calculations, where you're enveloping a vast array of results from, possibly a model or from, data, an Excel spreadsheet. Automating those little, those smaller processes can be very beneficial because they're quite simplistic in nature, some of them, but the process is repetitive, and for every design change or for every individual footing, you're laboring in a lot of time to get that done. We might use little bits of software like TED's calculation, for example, but having that connection between calculation and drawing as a live process, again, is removing layers of repetition. So it's a lot of those very rudimentary, quite small processes that actually is where you see the saving in terms of time, whereas with the big complex geometry is where you see projects where you might not have done in the first place. So the smaller sort of scale work is that quite rudimentary link between calculation and drawing is probably where that saving comes in.
Identifying the right case for it as a starting point, I think ultimately off the back of what you're just saying is kind of like taking a step back and looking at what you are doing currently in all of your processes, where you feel like asking people is a good point. Like, what are people pulling their hair out doing manually? Or if, say, conceptually something changes in a design at this stage, what are we now all going to have to do and what's going to take the longest? Is there an underlying workflow of principles that every single time we go back and go through those processes, we do those again manually, see if there's a way of trying to apply skills? And that's the second thing, because you do need the skills in the software knowledge to be able to start attacking those problems. And if those skills don't exist, then it's identifying people that would be keen in learning for them to do it and investing in that upskilling, or just hiring in. Because, so, like as Chris said, so many people are coming out of university or similar institutions with like qualifications in how to use these suites of software. So yeah, that's probably the right start.
Excellent, thank you. Very good, Dara. You stole my question. Sorry, it was a very good talk. Sort of on somewhat similar theme though. Both of your journeys and your companies sort of showed sort of self-directed learning as a sort of first steps, and obviously there are different time frames, and then obviously getting into a community and that shared knowledge. And the question I had really is, to what extent obviously is the fundamentals of saying the engineering, the architectural background, and then we see an industry worldwide where IT is downscaling, and I look at this and go, is there opportunities for people who maybe have been working in IT, maybe didn't take up an architectural engineering profession at the time because they didn't want to, and might go, actually I've got a skill set which could now be applied to construction and design?
I mean, absolutely. I mean, it goes hand in hand with still needing to retain those first principle knowledge base, the fundamental underlying understanding of, if you're going to be within engineering, the engineering, it still has to be described, explained, communicated in a simplistic manner. And that's with the geometry manipulation, the model management, the BIM environment, all of that exists in that same ecosystem. So there's lots of people that are coming into the industry with that really heavy IT experience, software development experience. Certainly at Buro Happold, we've got software developers coming in now who've worked elsewhere, but they have that ability to create good visualizations, for example. That supports the process of speaking with the contractors. Now you can demonstrate something easier. And so there are more people coming in, but there's obviously that balance between, can you code and are you an engineer who understands the fundamental principles, and is making sure you're not blurring that line too much is an important part of the process.
Yeah, I agree. I would say it's almost similar to, it's quite buzzwordy at the minute, but a lot of the AI things that people have been doing, and everyone seems to be looking and talking about it, but that is producing information, but it still needs someone who can sense check that to be able to make sure it's applicable. So if you have an external party, be that a human or a computer, who's giving you information, there still needs to be those QA processes in place to be able to ensure that what they are delivering you is what we are trying to deliver, which is buildings. Yeah.
Thanks.
Just like to say, thank you very much for an absolutely sensational presentation. Thoroughly enjoyed every single bit of it. I've heard it said that someone famous said that the purpose of computation is insight, and I think you guys have displayed that in that workflow and process that you're doing. But I do think there's a whole range of, it's not just one thing. When people talk about BIM and the like, I say now, what do you mean? Because it's a bit like IT, what do you mean? Because there's so many different aspects of it. Also, last year, or the year before, we had Bill Addis did a presentation for us on physical models, which was very interesting. And I do think about the human process of working with creation of models, even the working with the creation of analytical models where you physically have to go through and actually, it doesn't run or something doesn't work. Actually, that whole process of things breaking for you develops an understanding of where you want to go or where you need to go on it, I think, at a structural engineer's level. But to the other extreme, where you just you want to press the button and everything magically just kind of works out, right? So I'd just like you to comment on that. Do you still make physical models in your practice, or are there separate groups to do that? My second question is to do with model weight, particularly if you're going to such a high level of detail, particularly you're adding, say, the fire barrier, fire stop in your model, or enriching the models with a lot of, I know Revit, well, my experience before, used to have lots of problems with model size, so maybe just comment on that. And then the last thing is I suppose is to do a little touched on is open source of tools. You mentioned Speckle, but are there any other open source tools? I know I've come across Blender, BIM, and I'd like you to just comment on that. So those three things: traditional models, model weight, and open source tools. And I restrict myself to that.
That's right. Just that.
Sure, yeah. I'll try and comment on the model making, although I think it was more of a structural question. I do think that it's perhaps maybe a question of perspective on what is a model that is breaking for you. So if you're underpinning the principles of, a physical model in a kind of like entity that is breaking up at a certain point, quantifying that digitally, you're still pushing a digital model until it tells you it's going to break, and you're looking at that as a digital entity rather than a physical one. I would say that maybe that is just a new way of approaching seeing something break, rather than it being like, aha, it's snapped, it's turned red on a screen. Maybe, I don't know. Maybe tell me if you've done structural models.
Well, I guess it's increasing now, actually, with structural models. Almost again, there was a few of them around the office when I started 7 or 8 years ago, and then it's died down for a while. But now with the adoption of mass timber products, so your CLT, your glulam, your LVL, we're starting to use those products around. It's really difficult in the UK just now after Grenfell, but certainly in Europe with Switzerland and up in Canada, for example, there's huge industries that exist for that. A lot of that's CNC cut, so we can just scale the model down and get that done on a 2x4, a bit of timber, and play around with that a bit more. So it's a lot of that's about connection fit with timber. How does that connection go together? Slots, mortise and tenon connections, and we do play around with that quite often in a digital environment. You can watch live how the machine will cut your products, and you can also go and do that at a local, university might help you out with that. So almost now, because we have more digital environment, we can watch something happen live, but you can also start to push that through, because you've kind of got it in that environment where it can be translated into any language. So now we can send it straight to their machines to cut. It's almost, it's becoming more available to do models. With model weight, I think we challenge with the challenge is how much do you host locally on a server and how much is it on the cloud. It's definitely becoming heavier for sure, and it's really painful to open up. So we play around with having multiple models that are possibly referenced and what do you have visible, but it's a battle I think that everyone's trying to figure out. I guess still.
Yeah, I think at least personally, a lot of what I do is trying to help people with model management for sure, as well as this kind of stuff. And I do find that adding components such as fire barriers will increase file size, but not anywhere near as bad as general bad modelling practices will. So, I think it's about having QA processes in place and an approach to modelling components in an understanding of the level of information and detail that's required for certain stages, you know. Whereas a fire barrier can be justified as being important enough to be 3D modelled. The crazy intricacies on specific stonework, or maybe we inherited another architect's model not too long ago, and they had these like crazy detailed pillows on the beds in every apartment, and the file size was massive, and it's just like, what are you doing? We don't need to see the curvature in a pillow in a bed, you know. It's just not this isn't Sims. So yeah, that with file size. With open source, I do think that there are a lot of good practices in terms of programs like that. It's interesting about the kind of like intellectual property that people think about that. And I was saying to you only earlier about the lots of big like gaming entities now collaborating with Autodesk, and I think people have just basically come to realise the value in collaborating, in sharing that information, and leaning on an open source community for the for Dynamo myself, and I know it exists with Grasshopper as well. It's almost it's just like having an aid for you doing your job. It's so much easier to be able to see, like, I can't quite work out this one specific thing, I wonder if someone else has, and there's just like this, if it doesn't exist as a question, if you ask it within an hour, someone's going to be helping you probably. I think, open source, I'm not sure if it was a question around its value or which other programs, but yeah.
I guess, I mean, Speckle's a connector, I guess, between programs. So we haven't really, with using Speckle, you're not really recreating programs. You're linking all the tools you have together, and it's great, and it's growing massively. Obviously, the BHoM environment that Buro Happold work in does a very similar thing. But within Grasshopper and within Dynamo, they also have their own native tools. So I think Grasshopper now has Revit Insight, which means you can just directly push. You don't have to use more tools now. All of these companies are waking up to each other. There's no point in them. All of us work in all of them, so they might as well themselves link them all together, and they're starting to find. So a lot of them now have their own inbuilt tools to just push to the most common types. It's just becoming more popular now. Yeah.
That more was kind of what I was going to go on to about Speckle and being able to transfer within packages or from one package to another, which is great to have that compared to what was there the years gone by.
Yeah.
But going in, your graduate engineer now needs almost to be a software engineer at this stage. Is that right? You know, where we'd have to maybe do his 4-year degree course and then go on and do a master's in software development.
I mean, we got taught Matlab at university, which is just simple logic, whereas now you're just replacing that with, a lot of universities are now replacing that with Grasshopper. The student licenses come right down to allow for that. It's just transitioning your mindset from text-based programming to flow-based programming. So it's not really an addition, it's a replacement in a sense. I think the industry is waking up to the fact that you don't need everyone to be able to write text code, which is possibly not the way that a lot of engineers think. A lot of engineers, I guess, I certainly think with geometry, and I need quite a visual map in front of me, and that the flow programming is a logic table, it's a sequence. And so we don't need to be able to do both. I think the industry is moving towards the flow-based, certainly at university. So where I learned MATLAB and maybe little bits of VB script, nowadays they're replacing that with it. So it's not an addition, it's just a sort of a not always a replacement of the past, but a more up-to-date version of it.
I think that being said as well, I think, aren't they teaching kids in primary schools how to code now? I think so. So I think, 10 years we'll all be being replaced by these kids who have just been coding since they were 8 or something, I don't know. But I just think the threshold for entry into this sort of thought process has been lowered through the accessibility and more just widespread general use of them as general. So yeah, I think that was everyone.
Questions there?
Good stuff.
I'll just come down here to Thanks. You've done it before. So listen, thanks very much for taking busy
Yeah.
days that you have, taking the time to come over here and give us a talk. Great to have a joint architectural and engineering talk. Really, really appreciate that. Really good. Very thought-provoking. I think the interest is there. I think you've covered so much from an architectural engineering point of view, but also things like fire barriers and embodied carbon and all those things that are day-to-day on our mind. And I think it was interesting as well that you both mentioned that this isn't seeking to sort of fundamentally change the industry, that the basics are still there. And I recall someone saying that the same thing happened when AutoCAD was brought in 35 odd years ago, that all it was doing was digitising the drawing board. So remain to see what's happened in 35 years. But listen, if everyone here could give a round of applause, a sign of appreciation for the guys that are here. Great. I think I'm going to push that. And it should stop.